Hi, everybody. We're going to go ahead and do the exam, volume one. I'm going to go through some of the problems here. It says, which expression represents the volume of the sphere in cubic inches? We have a radius here of, looks like 15 inches. And you should know that we start with a diagram and then we write the formula. And the formula for the volume of a sphere is 4/3 pi r cubed. And of course, that's going to be 4/3 times pi times 15 cubed for this case, if that is, 15 inches. So you can use your calculator and simplify this. One thing we could do is take one of these 15s and divide it by 3. Since 15 squared is 225, and we multiply that by 5, it's 1125 times 4. We could get an answer. I can use my calculator just as easily. The problem with the 4/3 is that it has to be in parentheses if you use a calculator. You could put 1.33333, but that's only going to be an estimate. So 4 divided by 3 gives you 4/3. And then the pi key, if I want to use it. Now, a lot of times when they say an expression that represents the volume, they might want the exact volume, in which case we don't put the pi in. We leave the pi as a symbol, and then we put in the 15 cubed. So I'm going to multiply this by, and I'll put times, even though you don't need to, raised to the third power. The raised to button is right here. This means to the power of. That's going to give me a number, 4,500. So I didn't put the pi yet. This is 4,500 pi inches cubed. This is an expression that is the exact volume of that sphere. Now, if I want an estimate, I could put 4,500 times 3.14, which will give me an approximation. That's going to be 14,130 inches cubed. But that's only an approximation, and it's actually only accurate to here. That 30 is not accurate. The reason is because I only put in 3 digits for pi. Now, if I use the key, the pi key in my calculator, it'll be more accurate. So I could take 4,500 pi. Again, that's the exact answer as it's written. But when I hit enter, the calculator is going to use pi all the way out to here. This is going to be a very accurate answer. So 14,137.17 approximately. That's going to be very accurate, assuming this is. Now, if this is 15 approximately, then this is only about 14,000. If this is 15.000000000 and so on, then this one is the exact or the approximate answer. Very accurate. Okay, way more than you needed. All right, this one says the radius of a circular cylinder A is 4 inches, and the height is 5, I think. So we get a radius of 4. Notice that I start with a diagram, and the height, I like to use capital H for height, is 5 inches. I think these are in inches. And then it says that I have another cylinder, B, that's a lot bigger, and its radius is 12. I'm going to call it big R for 12 inches. And we've got a height, it's going to be bigger than this, but I'm just going to simplify it there. This is going to be the H in this case is equal to 20 inches. Okay, in this case, I'm going to use the little h because this is my little cylinder, this is my big cylinder. Now, if I look at the volume and how they're compared, the volume of the little cylinder, I'll call it VL for little, is pi r squared h. Now, the pi r squared is the area of the base. This is the base, that circle down there, and I multiply it by the height to get my volume. And in this case, I'm looking at pi. The radius squared is 16 because it's 4 squared. I'll just leave 4 squared there, times h, which is 5, and that's going to be 80 pi. Now this is an exact answer, and it's cubic inches. Now I'm going to do this one over here. This one is going to be the volume of the big cylinder, and it's going to be pi r squared, this time the capital R, times h. And of course, that's going to be pi. The radius is 12, and 12 squared is 144. And I'm going to multiply that by 20, and I'm going to get an answer. 144 times 20 is going to be 288 with a 0, 2880 pi inches cubed. Now, how are they related? In other words, how much bigger is this one than that one? And you could divide those to see. Now, when I divide these, I could put 2880 pi and divide by 80 pi in my calculator. The problem with doing that, and you're going to run into an issue. When I do this, I just want to show you something. You need to be really careful when you use division on a calculator. If I put 2880 pi and I divide it by 80 pi, I'm going to get the wrong answer. And there's a reason. Your calculator will follow order of operations. And what it'll do is it'll take the 2880 pi, multiply it by pi, then it'll divide by 80, and then it'll take that answer and multiply it by pi. Whenever you divide by something that's a fraction like this, I'll put it right here, 2880 pi divided by 80 pi. There are assumed parentheses around these things. And if you don't put the parentheses in your calculator, you will get the wrong answer. There's several things you could do about that. The most obvious one to me is to divide out the pi's. And then you have 2880 divided by 80. So 2880 divided by 80, which gives you 36. So what I'm saying is that if I divide 2880 pi by 80 pi, the two volumes, I get 36. So the large cylinder, it takes 36 of these to fill it. The large cylinder is 36 times as big. That's, perfectly acceptable. If you were going to put in the 2880 pi and divide by the other one, the 80 pi, it has to be inside parentheses, because otherwise you'll get the wrong answer. Oh, crud, I put the E in, sorry. That's what I can't see very well. 2880 pi, and if I divide that, divided by 80 pi in parentheses, sorry, we'll get it right this time. There we go, it'll give me 36 as well. It'll work. It's just you have to be very, very careful of dividing by a product. And there's other ways to do this, but there you have it. The large cylinder is 36 times as big. Another way to look at it is to say, well, the radius was 3 times as big, and I ended up squaring it. And the height is 4 times as big. And what you'll notice is that 3 squared is 9 times 4. Or 36. I could have done it in my head that way. All right. Volume of looks like it could be a observatory, something like that, where you've got a hemisphere, a half of a sphere on top, and a cylinder on the bottom. And it says, write the formula for the volume. So the volume of the sphere is 4/3 pi r cubed. That's the volume of a sphere. But I want half of that. What a lot of people are going to do is they're going to put divided by 2, which is not a good idea. Since you have a fraction, take half of it. That way you're multiplying fractions, and it's going to work out a lot nicer. The 2 cancels, and you get 2/3 pi r cubed, which is half of 4/3 pi r cubed. This is the volume of that hemisphere up there, or that half sphere. The volume of this cylinder is pi r squared h. So if I add these two things together, 2/3 pi r cubed plus pi r squared h, this is the volume of this weird combination figure. And I could just kind of draw it there or something, I guess. It kind of looks kind of funky, but there it is. This is the volume of this, it's called a composite solid. Another way to write this is to take out the pi r squared, because both of these have a pi r squared in them. So I could say pi r squared, and this is going to leave me with 2/3 2/3 r, and then this part is just going to have the h. So this is another way of writing the exact same thing. All I did was factor out the common factors. Okay, going way too slow. I apologize, guys. I will move it along here. Let's get to the more interesting stuff. It says we have a dowel. A dowel. It has a length of 12 inches and a diameter of 1 inch. And they want to know, if I cut out a 2-inch piece of this dowel, what is the volume? Well, I've got a 1-inch radius. Let me make it, I'm gonna expand it a little bit so I can actually see what I'm looking at. There's my piece of my dowel. I made it larger so you can actually see what's going on. The radius is 1/2 inch, 0.5 inches for the radius. And of course the height is equal to 2 inches. That's this piece right here that we're looking at. And if I take pi r squared h, it's going to be the volume of that little piece right here, and it's going to be pi times radius squared is 0.5 squared times the height is 2, and that is going to be 0.5 times 2 is 1, and instead of squaring it and then multiplying by 2, I could just multiply them all out like this. Pi times 0.5 times 0.5 times 2. And if you multiply these two together, you should know what you get, and then your answer is there. Now we wanted to round it off, so it's going to be 1/2 of pi. So I'm going to take 0.5 times pi, and they want me to round it, and it's going to be about 1.57. Approximately 1.57, and this is in cubic inches, isn't it? So that's the volume approximate. And it says rounded to the nearest tenth, That's going to be approximately 1.6 cubic inches if I round it to the nearest tenth. And there it is. Volume of a cone is a very special case. It's really nice. If you want to visualize something, imagine that it's part of a cylinder. Like this cone is cut out of an actual cylinder here. If you can visualize that the cone is inside the cylinder, what happens is the cone is exactly 1/3. So the volume of a cone, and I kind of like to put the picture there, 1/3 pi r squared h. And I'm going to take 1/3, the pi, radius is not 24, it's 12. And the height is 36. And I am going to multiply that all out and get my answer, maybe in terms of pi to get an exact answer in cubic feet. And if I wanted to multiply by 3.14 or use the pi key, I'll get an approximate. So you need to finish this one yourself, of course. Same thing here. We're looking at the volume of both cylinders. So we're going to take the volume of the small cylinder and the volume of the large cylinder, and we're going to add the two volumes together. This, of course, is pi r squared h, and this one is pi r squared h. The issue with this particular problem and the trick is that you have to use this distance that you're given right here and this distance right here to ascertain the height of this second cylinder, because they give you the height of the first cylinder and they don't directly give you the height of the smaller cylinder. They do give you the diameters rather than the radii, but you find the volume and add them together. This one, again, volume of a cylinder, pi r squared h. This one, volume of the cylinder, pi r squared h. This one, we've got a sphere with a 2-inch radius. The way you draw a sphere is you draw a circle and then you just put a belt around it, and it says that we have a radius of 2 inches. And they want us to find approximately the approximate volume in cubic inches. So you're looking at 4/3 pi r cubed. Notice I start with a diagram, then a formula. The volume of a sphere, I can put S for sphere, is equal to 4/3 pi r cubed. And of course the radius is 2, and I could substitute it in, get an exact answer in cubic inches, but I could also get an approximate answer. Number 10 says the volume of a right circular cylinder can be calculated by multiplying the area of the base times height. The volume of which solid can also be calculated in the identical manner. All prisms are the area of the base times the height. There are many kinds of prisms. There are triangular prisms that look something like this. There are square prisms that look something like, I'll just draw my front, I guess. Here's a square prism where it has a square on the base. There are rectangular prisms that are boxes that have a rectangle as a base. And you could even have a pentagonal prism, which has a pentagon as its base. Lots of possibilities there. Sorry, that's kind of a funky looking one, but let me just draw these a little longer. There we go. There's a pentagonal prism. Here's a rectangular prism. Here's a square prism. Here's a triangular prism. There's lots of ways to go. Cylinder has a height of 20 centimeters and a radius of 3. Again, you're going to find the volume of the cylinder. We should be pretty good at that. Number 12, you've got a height of 7 and a diameter of 10. Obviously, you don't want the diameter, you want the radius to find the volume. All right, the problem with triangular prisms is that there are 2 kinds of bases and there are 2 kinds of heights in this prism. First of all, this is the height of this triangle. This 6 feet is the base of this triangle. That I use little h for. This is the height of the height of this triangle. Here's the base of this triangle. I use little b to indicate that. Now, if you think of this thing as the prism when you put it together, this thing is a prism. It looks something like this. I'm going to draw it kind of the way that it's shown there, where this backside, you can't really see it, but I'm going to put it in there. There we go. It might look a little, there we go. If I just push this together, it's going to look something like that. I actually should have drawn it the same height, but anyway, not to scale. This is 18 feet, which is the height of the prism, not the height of the triangle. Different things. That's why I like a capital H for 3-dimensional height. The area of the base of the prism is the area of the actual triangle. So the triangle itself is the base of the prism. And if you take the area of the base of the prism, I'm going to use a capital B for the area of the base, it is equal to 1/2 base times height. That's the area of that triangle. That base is this distance right there, which is given right there, times the height of the prism, which is, of course, the 18, and you can find your volume that way. This one are the 2 that require that you do a little solving. And these are the 2 I should have probably started out with, because these are the more difficult ones. They tell you that the circumference of the top of the cone is 11 inches. That means the distance around this circle. Now, I know it looks like an oval, but it's actually circular. It's just we're looking at it at an angle. We need the radius in order to find the volume of that cone, if that's what they want. Yeah, they want the volume of the cone. So I need to know what the radius is. Well, you should know that the circumference is pi times diameter. Notice that I started with a diagram, and now I'm going to write a formula. Well, the circumference of any circle is equal to pi times diameter. And I could use this, and I could find the diameter and then use that to find the radius. Or I could just put 2r instead of the diameter here and solve for that. Either way works. Now it says the circumference is 11 inches, so I can put 11 inches in here. And that's pi times the diameter. Now what I can do is divide by pi on both sides, and I will have the diameter in inches, approximately. And it's going to be 11 divided by pi. That's going to give me the diameter in inches. And that will also let me know what the radius is. I have to, of course, divide this by 2 to get the radius. And then I'm going to use this radius that I found to find the volume of the cone. And the volume of a cone is 1/3 pi r squared h, where this is the height of the cone, and there's the height of the cone. That is not the slant height. That is the height. So see how it's up and down? It's the same as this one, up and down, straight up and down, not along the edge. This is the height. This is the diameter. If I solve for it, it'll tell me what the radius is, and I can just put the numbers in. The last one, the height of the cylinder below is 4.5 centimeters. There's the height. And the volume is 40.5 pi. So the volume of a cylinder is equal to pi r squared h. And remember, I start with a diagram, then I write a formula, then I substitute. Well, look at that. There's the volume. 40.5 pi is equal to pi times the radius squared times the height, which is 4.5. Now, I can divide both sides by 4.5 pi. So I'll put it in another color. Let me put it in red for you. I'm going to divide by 4.5 pi, divide by 4.5 pi, and I'm going to, the pi's cancel out, and I'm going to have 40.5 divided by 4.5. And that's going to give me the 4.5 cancels and the pi's cancels. And it's going to give me radius squared is equal to 40.5 divided by 4.5. Helps if I turn it on, I guess. And it gives me 9. Oh. Well, there we go. Centimeters. Dang. Put the wrong unit. Sorry. There we go. And if you want the radius, you have to take the square root of both sides, and you'll have your radius. And it says, what is the length of the diameter of the base? So make sure you answer the question asked, which means once you find the radius, you still have to tell them what the diameter is. All right, guys, hopefully this will help you out. I will make it so that you will be able to zoom through on any of the problems that you want to see. Not sure if I will or not. I might make you watch the whole thing because I didn't explain all the problems. Anyway, hope that helps. Have a nice day. Bye, guys.